This is the first in a series of videos on the normal distribution. And the normal distribution is probably the most common distribution, at least in introductory statistics. And there's a couple things about the normal distribution that you need to know. And the first is the shape. The shape is generally a bell-shaped, it's a bell-shaped curve. And it's symmetrical around the mean. And what we're going to do is we're going to use the symbol mu to mean the mean. Another thing to talk about is that it has no fat tails. In other words, the probability to be very far away from the mean is going to be relatively small. Not zero, but small. And the second thing is the distribution follows a specific pattern called the empirical rule that we'll do next. There are interesting things about the normal distribution. One is it's a well-defined function. Sometimes that function is specified. It's built into all of your graphing calculators. And the other thing is that it is just a generalization of Pascal's triangle. And though we won't talk about that in this video, it's kind of a cool operation. And also you can think about it as a generalization of what's called the binomial distribution, if you've studied that. And you don't have to know these two in order to appreciate the normal distribution that's true. And the specific thing that we want to talk about today is something that's called the empirical rule. And sometimes instead of the empirical rule, it's called the 97.5 rule. 99.7 rule. And it says simply this, is that 68% of the distribution falls between the mean minus one standard deviation and the mean plus one standard deviation. And in a similar way, 95% will fall between the mean minus two standard deviations and the mean plus two standard deviations. And 99.7 plus or minus 3 standard deviations. Let's look at an example. Let's say you had a given distribution where the mean was equal to 20 and the standard deviation was equal to 7. So usually the symbols that we'd use is mu equals 20, sigma equals 7. If we drew that, now what we find is that this is 20. If you add 7 and subtract 7, then you get 68% of the population would fall between 13 and 27. So the way to write that would be the probability that x is between 13 and 27 is 0.68. And we could also use less or equal, it wouldn't matter. But another thing that's important is that 68% of the distribution is within the middle of the distribution, That leaves 32% for the two ends. Since there's two ends and they're symmetrical, then exactly 16% will be in the upper tail and 16% in the lower tail. So another way to say that is the probability that x is greater than 27 would be 0.16. Or it could be greater than or equal. The probability that x is less than or equal to 27 would be, that's either 68 plus 16. Right, here's 27 right here. So 68% of the distribution plus 16 be 4, carry 1, 84%. Or another way to think about it is if 16% is greater than 27, then 100% minus 16% or 84% have to be less. And that's the example of the empirical rule. We can use the same example to look at two standard deviations. If mu is equal to 20 and sigma is equal to 7, then you have 95% would be within mu plus or minus 2 times sigma. Or in this case, 20 plus 2 times 7, or 2 plus or minus 14, which would be between 6 and 34. So if this is 20, and this would be 34 and 6, then in this tail would be, let's say 95%, that means 5% are in the two tails, but there's two of them, so this would be 2.5%, and this would be 2.5%, and this would be 95%. So the probability that x is less than 6 or less than or equal to 6 would be 0.025 or 2.5%. The probability that x would be greater than or equal to 6 would be 0.975. You get that two different ways. One is if it's less than 6 is 2.5%, then greater than 6 would be 100 minus 2.5%. Or you could just say the probability of greater than or equal to 6 would be 95 plus 2.5 or 97.5. And that's how you apply the empirical rule.